Thank you for joining me today. I will do solved examples. Just a reminder what we covered so far in module number 9, which is talking about section properties. I talked about the centroid. To figure out the centroid, we have to apply these two equations, x bar and y bar. X bar equals summation area times x divided by summation area. Y bar equals summation area times y divided by summation area. Keep in your mind, I will set up a table to figure out where is the centroid. We talked also last meeting about moment of inertia. And we have two values for the moment of inertia. One is called Ix and one is called Iy. Moment of inertia for a rectangle cross section equal parallel time perpendicular cube divided by 12. So for example, if you are looking for Ix, so the parallel to X is B, and the perpendicular to the X direction is H, cube divided by 12. If you are looking for Iy, parallel to Y, Y is here, so parallel to Y will be H. Perpendicular to Y will be B cube divided by 12. If you have right angle triangle, this is the centroid X and Y, so I equal parallel time perpendicular cube divided by 36. So the parallel to X is B. So Ix will be P time perpendicular to X is H cube divided by 36. Iy will equal parallel to Y, which is H, perpendicular to Y is B cube divided by 36. If you have a circle with a radius R or diameter D, the moment of inertia Ix equal Iy for the circle. This is a special case. Both of them equal pi time radius to power 4 divided by 4, or equal pi time diameter to power 4 divided by 64. And we learned also last meeting to use these expressions, your x and y must passing through the centroid of the rectangle. X and y must passing through the centroid of the right angle triangle. X and y, both of them must passing through the centroid of the circle. What will happen if you have a rectangle or right angle triangle or a circle and here is the centroid? However, your x-axis is here. Your x-axis is far away from the centroid with a distance d. Far away from the centroid with a distance d. Far away from the centroid with a distance d. In this case, your moment of inertia will equal parallel time parallel time perpendicular cube divide 12. This is the first term plus area time distance square. This is for rectangle. I equal for the right angle triangle BH cube divided by 36. This is the first term plus area time distance square. This is the case of right angle triangle. For the circle, I equal pi r to power 4 divided by 4. This is the normal term plus area time distance square. This is for the case of circle. I mean, if your x-axis or even y-axis far away from the centroid, I have to add another term to this one, another term to this one, another term to this one, which is area time distance square. And I did some examples last meeting, and I will do more today. Do you have any question before starting the first example? Any question? Okay, first example, we are looking to locate the centroid of this area. We are given area, looks like trapezoid, with a circle as a whole. So we need to locate the centroid. If you remember, to locate your centroid, we have to apply 3 steps. First step, I need to divide. Looks like for me, I will divide this area to 3 parts. Part number 1, the whole rectangle. Part number 2, the circle. Part number 3, this right angle triangle. So I will divide this given area to 3 parts. Then I will assume my references. The horizontal reference will be assumed at the bottom edge, and the vertical reference will be assumed at the left edge. This is the horizontal reference, and this is the vertical reference, and this is your origin point. Step number 3, I will set up my table. To set up your table, I will build up my table here. The first column, how many parts do you have? We have part number 1. We have part number 2. We have part number 3. What is the area of each part? So I have my calculator. The area of the first part is, this total distance is 300 millimeter, and this distance is 200 millimeter. So the total area will be 300 times 200 equal 60,000. Then part number 2, we have a circle. So the area of this circle looks like we are given the radius, 75. So by r square, the area equal 1767.4. But keep in your mind, this area will be negative, because the area of the circle is not a material, is not related to the surface. It's a hole. This circle is a hole, so I have to subtract it from the whole area. Part number 3 is right angle triangle. This base is 150, and this height equals 300. So half base time height will give you 22,500. So the first hint here in this problem, this circle is a hole, must be subtracted. How? By putting the area with a negative value. Negative means subtraction. Column number 2, I will put the distance x. What is the first part? I remember has a centroid here. The horizontal distance between this centroid and your vertical reference looks like 100. Also, the centroid of the circle at the same location. So the horizontal distance between the centroid of part number 2 and your vertical reference also 100. Part number 3 has this centroid. So the horizontal distance between centroid of part number 3 and your vertical reference, this distance, it will be 250. Do you know why? Because this little horizontal distance will be 1/3 of 150. So it will be 50. Then I will add 200. So the total distance, horizontal distance, will be 250. I will multiply column A by column X, A times X, to set up the new column. So 60,000 times 100, it will be 6 million. This area with a negative sign times 100 will be negative 1767140. This distance 22,500 times 250, I got 5,625,000. Go ahead and find the summation of this column and the summation of this column. This is what we covered last meeting. So 60,000 minus 17,671.4 plus 22,500. I got the total is 64,828.6. The summation here 6 million minus 17,607, 1 million, I think 1,767,140 minus, and then plus 5,625,000. This value equal 9,857,860. Two long numbers. So X bar, which equals summation area times X divided by summation area. This is the equation used to figure out where is the X bar for the centroid. Keep in your mind, this summation represents summation area because you are summation the column area. And this summation is summation area times X because you are making summation for area times X. So the numerator will be 9,857,860 divided by 64,828.6. So the X bar will be 152.1 millimeter. I will extend this table to 2 more columns. Y distance. What is the Y distance between the centroid of the rectangle and the horizontal reference? The Y distance equal 150. What is the Y distance from the centroid of the circle at the same location and the horizontal reference? It's also 150. What is the vertical distance between the centroid of the right angle triangle and the horizontal reference? I think this height will be 1/3 of 300. The total height is 300, so this one is 1/3, 300 will be 100. Then I will multiply this column by this column, area times Y. So 60,000 times 150, I got 9 million, I think. And negative 17,671.4 negative. Negative 17,671.4 times 150. I got negative 2,650,710. And 22,500 times 100, I got 2,250,000. Go ahead and find out the summation of this column. It will give you 8,599,290. This summation represents summation area Y. So the Y bar will equal summation area Y divided by summation area. This summation the numerator equal 8,599,290 divided by summation area 64,828.6. So the Y bar will be 132.6. So this is the centroid. This is part number 2. So I need to move horizontally 152. From the origin, I will move horizontally 152. Looks like I will reach here. And then I will move vertically 132. If you move vertically 132, looks like you will be here. This is the centroid for the given. Let me check. You said 152. I think 152. If you move horizontally 150, it will be here, just a little bit here. And then if you move the vertically 132, I think it will be here. Something inside the circle, probably. So this is the centroid. I'm not asking you to locate it accurately, but at least approximately. At this centroid, I will put my x-axis. Let me change the color. I will put my x-axis and I will put my y-axis. And this is called the centroid for the whole area as one unit. Keep in your mind, this vertical distance is y bar, 132.6. And this horizontal distance is the x bar, 152. $152.1. This is the first part of the problem. What is the, or where is the centroid? I have to divide your area to different parts. I have to put my reference. I have to set up this table. Then I will use these two expressions to figure out where is the centroid. Once you get the centroid, then I will start to think about the moment of inertia Ix and Iy. So if you would like to find out the value of Ix, I will set up a new table. How many parts do you have? Part number 1, part number 2, part number 3. What was the area of each part? Part number 1, if you remember, 60,000. Part number 2, if you remember, negative 671.4. Part number 3, 22,500. One more time, why part 2 is negative? Because it's a whole. I have to subtract this area. Does that make sense? Then, what is the moment of inertia for each part alone? For part number 1, it's a rectangle. Moment of inertia about x-axis, if you assume your x-axis is here at the centroid of this part, so parallel time perpendicular cube divided by 12, it will be 200 times 300 cube divided by 12. For the circle, it's a circle with radius 75. So it will be pi time radius to power 4 divided by 4. But this one will be negative because it will be subtracted. Also, for the right angle triangle, if you assume your x-axis is here, so parallel to x-axis will be 150. Time perpendicular will be 300 cube divided by 36. So 200 times 300 cube divided by 12. Oh my goodness. I have 1, 2, 3, 4, 5, 6, 7, 45 and 70. By time radius to power 4 divided by 4, I got this huge number, 24850,488 negative. 150 times 300 to power 3 divided by 36, I got 1125 and 50. Here you go. Then I will add another 2 columns, one for distance and one for area time distance square. What you mean by distance? Okay. So here is the x-axis for the rectangle, part number 1. However, this is the x-axis for the whole area. What is the distance in between? You can find it by subtracting 150 minus 132. It will be 17.4. The second area for the circle will be the same, 17.4. For the third area, this x-axis for the centroid of this right angle triangle has vertical distance equal 50. I'm sorry, equal 100, 1/3. And this vertical distance is 132.6. So the difference here, this distance will be 32.6. Go ahead and multiply this area by this distance square. So 60,000 times 17.4 square. I got this value equal, oh my goodness, 18,165,600. 18,165,600. This area will be negative 17,671.4 times 17.4 square. I got this area equal negative 5350193.1. And the final value here, 22,500 times 32.6 square. I got this value 239,121,000. 23,912,100. Then I will add this column together to find out the summation. And I will add this column together to find out the summation. So let's do the first one, this one. The summation here will be negative 5350193.1 plus 181,600. This value will be 36,727,506. And the summation here will be 45, 1, 2, 3, 1, 2, 3, 7 minus 2, 4, 8, 5, 0, 4, 8, 8 plus 1, 1, 2, 5, 1, 1. This value will be 53,764,951. No, actually it's 537,649,512. The final value for Ix will be this term plus this term will give you the final value plus 36,727,506. It will be 574,377,018. This is the final value for Ix. If you would like to figure out the value of Iy, I will set up another table. How many parts do you have? Part number 1, part number 2, part number 3. What is the area of each part? 60,000 negative 17,617.671 671.6, I think, 0.4 22,500. What is the value of Iy for each part? First part, the Iy for the rectangle. If your y is here, it will be parallel to y 300 time perpendicular to y 200 cube divided by 12. For the circle will be negative because it's a hole. By time radius to power 4 divided by 4. For the right angle triangle, the parallel to y, your y is here, so the parallel to y will be 300 time 150 cube. 300 time 150 cube divided by 36. What is the value of each? 300 time 200 cube divided by 12. I got, oh my goodness, 2 and 8 0. By time radius to power 4 divided by 4. I got negative 24850,488. 300 time 150 to power 3 divided by 36. I got 28125,000. Go ahead and find out the summation, by the way. It will be 203,274,512. Then I will add another 2 columns, one for distance d and then for area time distance square. This distance in this time, what is the horizontal distance between the assumed y-axis for each part and the actual y-axis for the whole area? You can subtract 150.1 minus 100. It will give you 52.1. The same will be for the circle. For the right angle triangle, here is the y-axis, here is the y. So what is the distance in between? I think the horizontal distance for this y-axis, it was 250. If you subtract 250 minus 152.1, I got distance 97.9. Go ahead and multiply this area by this distance square. So 60,000 times 52.1 square. I got 162,864,600. This area will be negative. This one will be negative 479647424. And this one will be 22,500 times 97.9 square. I got 215649225. Go ahead and add them together. It will be 330546401. It will be 330,546,401. So IY will be this term plus this term will give you a final value $533,820,913 millimeter to power 4. This is the value for IY, this is the value for IX, and this is the centroid of the given cross section. That makes sense? I will do one more example. For this one, don't be confused. This area or this cross section looks like this. So this distance will be 1 inch. This distance will be 8 inch. And this distance will be 10 inch. And this distance will be 3 inch. And this one will be 1 inch. That makes sense? I'm looking for this area. So you can redraw it to be easy. First step, go ahead and divide. It's up to you. It's up to you. If you decide to divide like this, so keep in your mind, this distance will be, this one is 1, so it will be 2. Because this one is 1. That makes sense? Here. And this one will be 7. And keep in your mind, the centroid for each part is known. Here is the centroid, here is the centroid, here is the centroid. Just a moment. Okay, so I can figure out where is the centroid for each part. So we have part number 1, part number 2, part number 3. I will set up a table. How many parts do you have? We have 3 parts. Part number 1, part number 2, part number 3. What is the area of each part? Part number 1, we have area, it will be 2. Part number 2, we have area, it will be 10 times 1. This distance is 1. So it will be 10. Part number 3, it will be 1 times 7, it will be 7. Small area, small values. What is the x distance for each part? So I forget to assume my reference. So I will put my horizontal reference here and my vertical reference here. So what is the horizontal distance between the centroid of part number 1 and your vertical reference will be 0.5. Part number 2, it will be horizontal distance 5. Part number 3, the horizontal distance will be 9.5. That makes sense? Then I will multiply area times x. 2 times 0.5 will be 1. 10 by 5 will be 50. 7 times 9.5, I got 62.5. Go ahead and find out the summation here and the summation here. The summation here will be 19. And the summation here will be 117.5. So x bar, which equal summation area times x divided by summation area, will equal 117.5 divided by 19. So it will be 6.2. I will add another 2 columns, one for distance y and then one for area time y. What is the vertical y distance between this centroid and your horizontal reference? The vertical distance will be 2. We have one here and we have another one here. What is the vertical distance between this centroid and your horizontal reference? Is 0.5. What is the vertical distance between this centroid and your horizontal reference? It will be 3.5 plus 1. It will be 4.5. If you multiply area by this one, will be 4. Area by this one will be 5. Area by this one, so 7 times 4.5, I got 32.5. Go ahead and find out the summation here. 40.5. So y bar will equal summation area times y divided by summation area. So 40.5 divided by 19. So the y bar will be 2.1. So what I need to do, I will move horizontally. Distance equal 6.2. So 6.2 looks like I will be here after this centroid. And I will move vertically 2.1. 2.1 means I moved up here. So here is the centroid for the whole area. And I can put the x-axis here. And I can put the y-axis here. Keep in your mind, this horizontal distance equal 6.2. And this vertical distance equal 2.1. Once you got your centroid and put x and y, I can set up another 2 tables. One for ix and one for iy. Let me do one for ix. So how many parts? Part number 1, part number 2, part number 3. What is the area of each part? If you remember, 210.7. What is the moment of inertia Ix for each part alone? So for part number 1, I have 1 times 2 cube divided by 12. Part number 2, the parallel to X is 10 times 1, 10 times 1 cube divided by 12. Part number 3, the parallel to Y is 1 times 7 cube divided by 12. Go ahead and find out the value of each and find out the summation. Then I will add another column for distance. What is the distance between x-axis for this part and the x-axis for the whole area? This part has x-axis at distance equal to from the bottom. And this one has distance 2.1. So the distance in between will be 0.1. X-axis here for this part at vertical distance 0.5. This one at 2.1. So the difference will be 1.6. This x-axis is here. So the distance in between this one to the bottom is 4.5. This one is 2.1. So 4.5 minus 2.1. I got distance 2.4. Go ahead and multiply this column by this distance square, area times d square. So this one times this one square, I got 0.02. this one time this one square, this one time this one square, and find out the summation. So your Ix will be this summation plus this summation. You can find out the final summation. Also, you need to do another one for Iy. Set up your table, number of parts, area of each part, Iy for each part, distance, area time distance square. Part number 1, 2, 3. I will find out the summation here and the summation here. Then the final Iy will be this one plus this one. Does that make sense? So if you look to these examples and the previous examples I solved on Monday, you will find that all problems will be the same process. You need first to locate your centroid by setting up this table, and then you need to set up another 2 tables to find out the value of Ix and to find out the value of Iy. Keep in your mind, if you have any hole like this circle, it's a hole, so I have to subtract it. Most of the time, you will find negative value for this part. Anything else, we don't have any negative sign because everything else will be added together.